Newton's third law of motion. Okay, Newton's third law of motion is about action-reaction force. Every action force has a reaction force that is equal in magnitude. Okay, I just want to highlight this. They are equal in magnitude but opposite in direction. The word opposite, you must use the word opposite. Don't use different direction. Many students say, oh, equal. Okay, many students says equal in magnitude but different direction. Different direction is wrong. Why we say different direction is wrong? Because if different direction, not necessarily opposite. The actual definition for Newton's third law must be opposite in direction. Different direction can means it can means like you see this force 1 and force 2. They are different direction. These two, they are different direction, yet they are not exactly opposite. Yeah, they are not exactly opposite. But Newton's third law, the action-reaction force must be exactly opposite. So different direction is wrong. Okay, the two force must be exactly opposite. F1 backwards, F2 forward, exactly opposite. Must be exactly opposite. So the word opposite is very important. The word opposite is very important. Don't say different direction. Must say opposite direction. Okay, that is Newton's third law. Must be exactly opposite. You look at these two action-reaction force. This FAB is the action force, and this FBA is the reaction force. So I just want to write it down here. This is the action, and this is the reaction. This is the contact force. Like this tension also. Okay, this one is the action. This one is the action. And this one is the reaction. All of them, they are equal force. Yeah, they are equal in magnitude but opposite direction. I have two examples here. One is the contact normal force, and another one is the tension. Let us look one by one, and they must act on two different objects. They must act on two different objects, not act on the same objects. Act on two different objects. You see, like the action force act on block B. Reaction force act on block A. Like this one also, the action force act on block B, and reaction force act on block A. So they act on two different objects. Okay. Let us look one by one. First of all, we look at the contact force or the normal force. You see, this person is pushing on block A. He doesn't push on block B. He push on block A. You see that? This person push on block A. It is the block A push block B. We must think like this. This is the human push block A, and then block A push block B. Okay? So this person never push block B. He push block A. Think like that, yeah? Person push block A. The block A push block B. It is a block A who push block B, not the person push block B. Okay? Now, I just want to focus. Actually, the force on these two objects is not just this action-reaction force. There are other force like the weight of block B, normal force on block B, and then the external force from the human. Okay? Actually, it's much more complicated. The actual, the actual free body diagram. There are other forces too. There are external force from the human. Even got friction on the floor. And then we have the normal force, and then the weight, and then the B also has normal force B, normal force A. So, but we're not going into details because I just want to focus on the contact force. I just want to rub off all the other forces. I just want to leave the contact force in between the block. Okay. When the person push block A, the block A also push block B. The sentence I say that block A push block B is the action force. So block A push block B with this force FAB. That's called action force. This action force actually comes from block A. Yeah. So I just want to write it down here. This action force actually from who? From block A. Okay, from block A. That's the action force, you know, the contact force. We call it contact force, or the normal force that we learned before about the concept. We learn about contact force over here. We learn about this normal force. Normal force is not just the surface you put the block on. Yeah? It's not just the table, not the ground, not just the ground, not the inclined plane only. It's also between the block, like this one. You see, in between the block also has normal force. But we have one special name for between block. We call it contact force. Contact force. These two surfaces must come in contact. These two blocks must come in contact. Only have this contact force. If not come in contact, the block A and block B doesn't touch each other. Separated. If both A and B separated, they won't have this contact force. They must come into contact. Block A and block B come into contact. Then only got this contact force. Got this normal force. Understand? Okay. Right now, let's look at FAB. FAB is this action force come from block A. What I mean is block A push block A push block B with this force FAB. Okay, so FAB actually come from block A. This is action force. Why we write as FAB? Yeah, why we write as FAB? FAB means FA on B. FA on B. That means, or we can, other words, we can say FA pushes B. That means it is the A on B. Who experienced the force? Who experienced the force? B experienced the force. B is the one. Yeah, B is the one. I just want to highlight it. Yeah, B is the one who experienced. B is the one who experienced the force. Yeah, B feel the force. Yeah, it means that B feels the force. Yeah, B feels. The B feels the force. The B feels the force. B experiences the force. Yeah, then A pushes B. A pushes B. FAB that means A push B. Who experiences the force? Who feels the force? The B feels the force. Yeah, it's like FA pushes B. That's action force. So this force actually comes from A. This FAB actually comes from A because it's A pushes B. So A pushes B, so this force comes from A. Understand? Now, B feels that A pushes it. Yeah, B feels that. Maybe I should write something here. Okay, so make it larger. Okay, so I hold on a second. Now I make it much clearer. I made it much clearer. Look at this one. This block B, block B feels the block A pushing on it. Yeah. So this force from block A. Okay, we can say that block B. Look at this one. Block B feels. Block A is pushing it. Is pushing it forward. Pushing it forward. So block B feels the FAB. Look at, yeah. Can you see this one? Feels the. Maybe I should highlight it. Highlight it. I should highlight these words. Yeah. Highlight these words. Highlight these words. Highlight these words. This sentence is the best. Okay. This sentence is the best. Look carefully. Block B feels block A is pushing it. So block B feels the FAB. FAB. Okay. That means block A is pushing block B with FAB. This force. This force comes from block A. Now, this block A also feels that block block B is opposing it from moving forward. You see, this pushes block A to move forward, but block B is like inhibiting it from moving forward. You know, it's like blocking the way. Block B, you know, block B is like blocking the way. Blocking the way of block A. You understand or not? Block B is like blocking the way for block A. So block A feels this reaction force from block B, which is FBA. Okay, block A feels that block B is like we can say blocking in front. In front. Yeah, block A feels like block A feels block B is blocking in front. Block A feels the block B is blocking in front. The blocking in front feeling is the reaction force FBA. This one FBA, why we write FBA? FBA means FB on A. Okay, FB on A. Maybe write this one. Write as FB on A. Yeah, or FB on A. Or B pushes A. B pushes A. Who experience a force? Who experience a force? A experience a force. A experience the force. You see that? A experience a force. The letter behind shows that who experience a force, who feels a force. It is the block A who feels this force. Like this one, block B, FAB. He feels FAB. Block A feels FBA. The letter behind is the one who experience. You know, the letter behind, like this one, the letter behind is B. So it is B who experiences this force. The letter behind is A. So it is A who experiences this force. Understand? So this FBA is actually come from block B, because it's like this block A feels like block B is blocking the way, you know, blocking the way. Without block B, A can move forward much easier. Without the block B, block A can move forward much easier without the resistant force from without the resistant force of FBA. FBA is like the resistant force, like B is blocking the way. So BA cannot move freely because got FBA, got the reaction force from block B. So this reaction force from block B. Just want to write it here. This one is from block B. Understand? So this action and reaction force, they are equal in magnitude. The action and reaction force, these two forces, they are equal. You can see here block B is a smaller mass, smaller object, but block A is a bigger object. Do we say that, oh, bigger object pushes smaller object with much bigger force? No. Even though they have different mass, block A might have a bigger mass, block B might have a smaller mass, but the action-reaction force they experience, they are equal in magnitude. You look at here, FAB equal to FBA. In magnitude, in terms of magnitude, they are equal. It's just the direction which is opposite. That's why you have negative sign. Because let's say we put FAB positive, FBA will get negative. In terms of direction, they are opposite, but in terms of magnitude, they are equal, although they have different mass. So don't say that, oh, big mass push small mass with a bigger force. No. Big mass, small mass, big mass or small mass, they experience the same contact force, same action-reaction force. They're equal in magnitude, just opposite in direction. Okay, we can say that B is being pushed forward by block A. A feels that block B is blocking the way. That's why we have FAB and FBA. Action force is like A push B forward. FAB is like A push B forward. FBA is like B is blocking the way for block A to move forward. Yeah, it's blocking the way. Without block B, block A can move forward much easier. That is what it means by FAB and FBA. Okay? Look at block B feels the block A is pushing it, FAB. Block A feels the block B is opposing it from moving forward or blocking in front, FBA. Okay? Now, okay, different mass, yet they experience same force, same action reaction force. Now, look at another example. This is about pulling force. Last time is being pushed. Okay, last time is the person push. Now this time person pull. We have external force pulling forward, pulling behind. So this entire object they move to the right. Okay, so of course there are other forces. Yeah, I don't draw all forces over here. Yeah, all jumble up later on. Yeah, we have a pulling force here. We have all the weight, but we I don't draw all that. Okay, I just concentrate on the forces in between the block, which is the action reaction force. The tension. Last time I did touch about tension force. In the first video. I did mention same string, same tension. Why is that? Now I explain. Why? Like you see this string. Why this tension T21 is equal to T12? Why this tension equal to this tension? Why on the same string? Why on the same string they have the same tension? Because this is another example of action reaction force. So that's why same string, same tension, because they are equal in magnitude for action and reaction force, just opposite direction. Yeah, just opposite direction. That's why we have negative sign. Okay, you see the opposite direction. You see T21 is to the right, T12 is like to the opposite direction. If we make this block straight, yeah, if we make this block straight like that, you see, this is number 1, this is number 2. Okay, so this is T21, this is T12. See, they are opposite direction actually. Yeah, although it seems one horizontal, one vertical, but in reality, this T21 and T12 they are opposite direction. They're opposite. We make it straighten, become both horizontal. We can see that T21 and T12, both of them, they are opposite direction. Okay, they are same string, same tension. Okay, okay, action reaction force. Now look back to this one. Yeah, look back to this one. Okay, clear. Now look at here and also the wording below. You will understand more. So again, different mass. Block A is a bigger mass. Block B is a smaller mass. Do we say that block A pulls block B with much bigger force compared to block B pulls on block A? Same force. You see the arrow, same length, isn't it? Same length. So the action reaction force, they are equal, just opposite direction. They are still equal in magnitude, but opposite direction. So same string, on the same string, they have the same tension. Okay, so this tension, they act on two different objects. TAB act on block B. TBA act on block A. Don't say that this TAB and TBA experienced by the string. No, this TAB experienced by block B. This TBA experienced by block A. They act on two different objects. Don't say though this tension experienced by the string. No, there's no object in the string. Actually, this tension is for block. This tension TAB is for block B. This tension DBA is for block A. Okay. We have two different free body diagram. Later on we will draw and show you how we draw the free body diagram for each body, each object. We have two objects here. We will have two free body diagram. Okay. Now let's just concentrate on TAB and TBA. Okay. Now why block B? We write TAB. Who experienced TAB? It is the letter behind. Again, I want to say it's the letter behind who experience, who feels the force. It is the letter behind, which is B, who experienced the force. So that's why block B is the one who experienced TAB. Because it's like, how to write it in another words? How to write it in another word? TAB is actually TA on B. Or we can say TA pulls. Who pulls B? Who pulls B? Look at this person. This person pulls block A. This person doesn't pull on block B. It is the block A who pulls block B. Again, the person pulls block A. Block A pulls block B. Block A pulls block B by this force, TAB. Okay? So TAB actually come from who? Come from who? Come from block A. Come from block A. Yeah, that means A. You know, when these two blocks go to the right, actually it is the block A who are pulling on block B. Pulling on block B. Block A pull block B by TAB. Yeah, it's like A pulls B. Who experienced the force? It is the B who experienced the force. It's the letter behind. It's the letter behind. It's A pulls B. So block B feels block A is pulling it forward, pulling it to the right. Yeah, block B feels block A is pulling it by the force. Okay, we use this is the FA. We put tension. Actually, we should put tension instead of sorry. Hold on a second. Yeah, I corrected it. Yeah. So block B feels block A pulling it. So this is TAB. That means A on B. Tension of block A on B. On B. So yeah, this this tension come from block A or A on B. Okay, A on B. So block B feels block A is pulling it. Okay, and then we go forward to the block A. Block A instead feels that block B is like A feels the block B is like dragging behind. You know, without block B, yeah, if we cut off this string, we cut off this string, block A can move to the right much easier. Can move to the right much easier without the block B. But because we have this string and B is like dragging behind, A move forward much harder because B dragging behind. So the feeling, block A feels that block B is dragging it behind from moving forward. So block A, what block A feels? What actually feels by block A? The tension TBA, which is the reaction force it experienced. So block A experienced this reaction force. This reaction force is block B is actually dragging it behind from moving forward. It feels the tension TBA, the reaction force. So this reaction force is actually block B dragging behind. So actually this reaction force comes from who? From block B. Who experienced a force? Who experienced a force? Block A who experienced a force. Block A who experienced a force. So it's like this force is actually B on A. TB on A. Who experienced a force? A experienced a force. And this force come from who? This force come from B. This force come from B. Understand? This reaction force come from B. B dragging behind. This tension come from B. B is dragging behind. Who experienced this force? A who feels the dragging force. A who feels the dragging force. The letter behind is always the one who experience. Okay. So block A feels block B is dragging behind. So block A is feeling this reaction force from block B, which is the TBA. Yeah, dragging behind. Without block B, A can move forward much easier. But because of this reaction force from block B, A move forward harder, or slower. Okay, that's action reaction force. Action reaction force equal in magnitude but opposite direction. Okay, X on two different objects. Yeah, X on two different objects. Yeah, why it says X on two different objects? Because we can say block A experience a force. Block A experience a force. Block B also experience a force. You see, block A experience this reaction force. Block B also experience the action force. So they act on two different objects. Okay, finish that. There's action reaction force equal in magnitude opposite direction. Now let's draw free body diagram. Yeah, so look at this one. Let us draw one by one. Okay, so first of all we have three objects. Remember the key here. We have three objects. We must have three free body diagram, isn't it? We must have three free body diagram. Okay, so I simplify things. I don't go to draw other unrelated component. I just draw the component which is parallel to the acceleration. Okay, I don't draw the component which is perpendicular to acceleration. I just draw the component of forces which is parallel to acceleration to make things easier. Yeah, so yeah, acceleration like this mass 1 and mass 2, acceleration is in x component, so I don't draw y component. I know that y component also have force, like the mass 1 has the weight 1, yes, the normal force 1. Yeah, mass 2 also have weight 2, normal force 2. But I don't want to complicate things. I just want to concentrate on the tension. Tension. I don't want to include all the other unrelated component. Yeah, so I leave it out, all the weight, all the normal force. Okay, I just want to find the forces like the tension. You see that the tension which is parallel to the acceleration. Okay, so for mass 1 and mass 2, it is the x component. I just look at x component. I don't look at y component. Okay, I want to make things easier. So now, okay, let's start. Yeah, let us start. Another thing, maybe I can put this is a rough surface. Maybe this is a rough surface, so I can expect they have this friction. Okay, acceleration means they have a kinetic friction. Yeah, so look at mass 1. Look at mass 1. Okay, look at mass 1. Okay, so mass 1, you have look at the free body diagram. Mass 2. Okay, mass 2. I think never mind also. If you want to include all the components, also never mind. I'm sorry about that. So to make things complete. Okay, never mind. I include all the components, both x and y component. I include. Yeah, I include both the x and y component. Now, how to draw the correct free body diagram for this? Okay, I'm sorry. Yeah, for earlier part. So how to draw? Okay, look at mass 1. Mass 1, we can say it experience the tension. Okay, so this should be T21. And then who experienced the T21? It is the letter behind 1, isn't it? 1. Okay, and this should be the T12. This is T12. Okay, so this on this string, it has this is a action reaction force. These two forces, they are equal. They're equal. And then between 2 and 3 also they have one string, so they have same tension. There's same tension. So this force should be this force should be T32, and this force should be T23. This is T32, and this is T23. Okay. Now, okay. So now let's draw the free body diagram for mass 1. Remember, only a point mass. Only a point mass. We draw the axis first, x and y axis dotted. Okay. So mass 1 has what force? Yes, a rough surface. Okay. So how to draw? So this is the T21. This is the T21, and then we has the weight. Okay, it has the weight. Okay, now I put all the components, never mind. This is the weight one, and this is the normal force for one, and the friction. It has a friction going behind, isn't it? Opposite the direction. So friction, this is the kinetic friction for block 1. And then it has acceleration to the right. We must draw the acceleration to the right. Draw on just beside the dot. This is the free body diagram for mass 1. Now, how about the mass 2? Mass 2 is okay. So it has the tension to this direction. Okay, T12. Yeah, like mass 1 is like dragging behind, and then but it also has the T32 forward. Yeah, T32 going forward. What other force it experience? Don't forget, this is a rough surface, so it has a friction going behind. So it has a friction going in the opposite the direction of motion. So this is kinetic friction for block 2. And then it also has its own weight, put as W2, and this is normal force. This is the normal force for block 2. Okay. So you have so many forces here, and don't forget you must draw the acceleration also. Acceleration to the right. Acceleration to the right. So remember, acceleration draw beside the dot. Yeah. Acceleration. So you see, the friction always opposite the acceleration. You see, friction always opposite the direction of motion. You see, friction 1 also opposite the direction of motion. Acceleration to the right, friction to the left. This one, acceleration to the right, friction 2 also to the left. So remember, okay. And then for the mass tree, okay, how to draw the mass tree? What force experience? Okay, let's draw. First, let's draw the axis. Okay, axis, x and y axis. So what force it experience? It experience the tension. Okay. Let's draw the point mass first. Point mass. Don't draw the block. Just draw the point mass. Draw the point mass. So it has the T23, and then it has a own weight. Don't forget the own weight. Own weight going downward. Weight 3. What force? No more. This block is not in contact with the surface. You see, not in contact with the surface. No. So no normal force. No normal force. No friction also. No friction. So just these two forces only. So what's the direction of acceleration? Downward. Okay, downward. Okay, remember, understand? Again, if you want to apply the Newton's second law of motion about this total F equal to ma, the total F equal to ma, we use the convention, follow acceleration positive, opposite acceleration negative. So this one also, like you see, this one going downward, you should remember follow acceleration positive. This one positive, opposite acceleration is negative. Okay, like this one, mass 2 going forward is positive, going to the behind is negative. Okay, like mass 1 also, follow acceleration is positive, opposite acceleration is negative. Opposite acceleration is negative. Then we apply the formula here. We need to build equation F equal to ma. Okay, that's the free body diagram. You see, we have 3 objects: 1, 2, 3, mass 1, mass 2, mass 3. We have 3 objects. We must have three separate, you know, 3 separate free body diagram to represent them. Yeah, don't draw combined. Yeah, don't draw combined. Okay, yeah, and then acceleration must always right beside the dot. Don't draw on the dot. Acceleration must always beside the dot. Okay, now that's the, you know, that's the action reaction force. This tension is the action reaction force. Same tension. Yeah, you see, this is the same string, same tension. So we can say T21 is actually same as T12. In terms of magnitude, they are equal. Direction is opposite. But this is for the tension. But for this one, another string. You see, another string here. This one, oh, another tension already. This one, another tension. So, you see, same string, same tension. So T21 and T12 same tension, and then T32 and T23 same tension. This T32 and T23 experienced by two different objects. So T32 and T23, they are equal in magnitude, just opposite direction. Yeah, they're equal in magnitude. All right, in terms of magnitude, they're equal. Okay, I don't put the negative sign here. We know that is opposite direction already. Yeah, just the magnitude, they are equal. Okay, so remember just that this tension T21 and T12, these two, they are equal. These two, they are these two force they are equal. And another thing is this one and this one, this one and this one, they are equal. You see that? Maybe I should highlight this 332 and this 323, they are equal. They're equal. Understand? They're equal. And then one more thing about the this one, T21 and T12, they are equal also. So you see, if you solve the equation for mesh 1, let's say you get the T21 here, later on you can use the value of T21 here to put inside the value of T12 here, because they are equal tension. That's how you going to solve later on the equation for total force Fx equal to MAX. Yeah, you from here, from mesh 1 you can do to mesh 2, and then from mesh 2 you get the T32 here. You can substitute the 3T2 here into T23 here to do for mesh 3. So it's like chain reaction. You get one, you get another one, you get another one, you get another one. Yeah, that's how we substitute, because action reaction force, they are equal in magnitude. That's how we do it. Understand? Let us do just now it's about tension. Now about contact force. Contact force also the same. Yeah. Look at these. You have three mesh here, means you must have three separate free body diagram. Okay, let us first look at the contact force. Okay, so let us first look at the contact force between 1 and 2. Mesh 1 push mesh 2. Mesh 1 push mesh 2. This is normal. We put as contact force F1 on 2. Mesh 1 push mesh 2, so F12. But mesh 2 is okay. Actually, this one has a pushing force over this side. This is the pushing force. This is the pushing force, or this is actually external force. Understand? External force pushing it forward. Yeah, that's why acceleration. The whole system accelerate to the right. Pushing force first, and then mesh 1. Yeah, pushing force push on mesh 1. Mesh 1 push on mesh 2. Mesh 2 push on mesh 3. Understand? Pushing force does not directly push mesh 3. Pushing force also does not directly push mesh 2. It is the mesh 1 who push mesh 2, and then it is the mesh 2 who push mesh 3. Remember the sequence. Okay? So mesh 1, okay, pushing force push on mesh 1. Mesh 1 push on mesh 2. Mesh 1 push on mesh 2 with F12. And then mesh 1 is actually blocking the way. Mesh 2 is actually blocking the way of mesh 1 with blocking the way of mesh 1 with F21. Okay, this is the contact force, a pair of contact force we have here, and they're equal force. Now mesh 2 is pushing on mesh 3 with this force. Mesh 2 is pushing on mesh 3 with F23. But mesh 3 is blocking the way of mesh 2 with equal reaction force of F32. So this is another pair of action reaction force over here. And they are equal in magnitude, just opposite direction. Okay, now let us draw the free body diagram. So we have mesh 1, we have mesh 2, we have mesh 3. Okay, put this as mesh 1, this is mesh 2, this is mesh 3. Okay, just a dot only, it's a point mass, not an object. Don't draw the square. Don't draw the square. For free body diagram, always use dot as point mass. Only draw point mass. Don't draw the object square. Okay. Now let's draw. Okay, mass 1 feels the pushing force directly. So you should put pushing force here. Pushing force. Do we draw pushing force over here? Do we draw the force towards the point mass? No, we always remember when drawing free body diagram, all the forces must outwards from the dot. All forces must outwards from the dot. Don't go inward. So that means the pushing force you cannot put over here. You must put to the other side. You must put this to the other side. Don't put it over there. Yeah, don't put that over there. So okay, I redraw. Yeah, pushing force you need to put on the other side. Put it outward. All forces must outwards. Yeah, all forces must outwards. Outwards from the dot. Outwards from the dot. So don't put the pushing force. Don't put the pushing force over here. Yeah. Don't put the pushing force over here. All forces must outwards from the dot. Okay, so pushing force over here. Okay, just put it here. Okay, all forces outwards. So now, pushing force is over here, and then what experience? It experienced this. Mass 2 is blocking behind, isn't it? It feels the mass 2 is blocking behind. So this is the F21. And then also it experienced what other force? It experienced the it has its own weight W1, and also it has the normal force 1. Let's say this object is this surface is a smooth, so we can no friction. If smooth, no friction. Yeah. If got friction, it must be the other way lah. Friction must be over here lah. FK1 over here. But let's say this is a smooth, unlike before that, just now it's a rough. If rough surface, you have friction. But now it's a smooth surface, so you have no friction at all. Yeah, no friction. So no need to draw the friction. Okay, because it's a smooth surface, or we can say no mu is given, right? No mu is given. So it's a smooth surface, no friction. So acceleration also you must write beside. Acceleration you must write beside the dot. Acceleration, like that. Okay. Now look at mass 2. Mass 2 is feeling that mass 1 is pushing it forward. He feels that mass 1 is pushing it forward. So this is F12. But mass 2 feels that mass 3 is blocking the way. Yeah? Mass 2 feels the mass 3 is blocking the way. So is mass 3 is blocking it behind. And then it has its own weight 2 and normal force 2. One thing I want to tell you is this weight you must identify it with subscript W1 and W2. Don't just put W normal force. No, this is wrong. Don't put without subscript. You must have subscript. Understand? You must have subscript. So this one you must label because they have different weight. They have different normal force. So you must put as W1, W2. This one also have different normal force, N1 and 2. Okay. And then acceleration just draw beside. That's it. There's no pushing force here. You see, pushing force only on mass 1. Mass 2 didn't experience the pushing force, so there's no pushing force. What mass 2 experienced is just the F12. That's why I say. Mass 1. It is the mass 1 who pushed mass 2. It is not the pushing force that pushed mass 2. I know F12 actually is a part of the pushing force. I know. F12 actually is a part of pushing force, but pushing force does not push mass 2 directly. It is the mass 1 who push mass 2. So this F12 actually comes from the mass 1. Actually, of course, F12 actually is part of pushing force. Okay, I just don't want you to label pushing force over here, which is wrong. I just don't want you to label pushing force. You think that, oh, pushing force push a whole system, and you put the pushing force over here also, which is wrong. Pushing force only on mass 1, and then the pushing force has passed down the F12 to mass 2, and then passed down, the pushing force passed down F12 to mass 2, and then also pass down the F23 for mass 3. So don't draw the pushing force here. It's wrong. Pushing force only for mass 1, because pushing force pushes mass 1 directly, and it is the mass 1 who push mass 2 with F12. Okay, clear? Now, lastly, about the mass 3. Mass 3, who pushed mass 3? Who pushed mass 3? It is the mass 2. Mass 2 who pushed mass 3 with F23. And then, is there anybody in front blocking the way? Is there anybody in front blocking the way? Nobody. So there's no blocking force. There's no blocking force in the opposite direction. There's no blocking force to the left. There's no blocking force to the opposite direction. Okay. Block mass 3 only feels mass 2 pushing forward. Okay. And then it has its own weight. Weight going down, and then it has a normal force going up, and then it has the acceleration to forward, acceleration forward. Again, so follow the sign convention for Newton's second law. Follow acceleration as positive force, opposite acceleration as negative force. So that one, see, look at acceleration to the right. Acceleration to the right, so force going to the right we put as positive, force going to the left negative. You see, mass 2 for acceleration going to the right, acceleration to the right is force to the right is positive, force to the left it should be negative, because force to the left is opposite the acceleration. Okay, and then mass 3, force to the right is positive, force to the right is positive because it follow acceleration. Okay. There's no force to the left, so of course, if got force to the left is negative. So that's how we build equation. So again, this action reaction force, they are equal in magnitude. Like this F21 you get from here, you later on you get the value, you can substitute to here, because they are equal. They are equal in magnitude. And then after you get after you solve, and then you get F32. After you get F32, also the same. Action reaction force, they are equal in magnitude. F32 you get from here, you can substitute to F23 here. So again, you can solve for mass 3 because they are equal. Action reaction force, they are equal in magnitude, just opposite direction. So that's how you do the Newton's third law of motion. Okay. So I hope you understand and clear. Remember, action reaction force, they are equal in magnitude but opposite in direction, not different direction, opposite in direction. Okay, so that's it for these questions. Okay, thank you and bye bye. Look at the problem solving video.